Well, my name is Elizabeth Vandermark, and I work for Smith Group, and the building that I chose to go into greater detail on is the Matthaei Botanical Gardens, which is a personal favorite of my family's here as a resident of Ann Arbor. It's a really extraordinary building architecturally, and it's a wonderful building to have at our fingertips here to both study and to enjoy, and I hope you'll enjoy it along with us as we go through this tour today. The University of Michigan received 300 acres of land in 1957 from Frederick C. Matthaei Sr. and Mildred Haig Matthaei for use as a botanical gardens in perpetuity. Alden Dow was the architect hired to design the main greenhouses, conservatories, and natural areas closest to the buildings. Phased construction of the project enabled the move of the permanent collection of indoor plants by the mid-1960s from its previous situations all over Ann Arbor. Site development based on landscape architectural plans designed by Edward A. Ashtott of Ashtott and Grissom Associates of Detroit. The new botanical gardens were dedicated in June of 1961, and the conservatory is believed to be the largest one operated by a university in the country. One of the most intriguing things about this particular building is that much of the original information is still here in-house. And one of the things I'd like to share with you is the original plans for the conservatory as Dow laid it out. This is not actually how it got implemented. It was changed just prior to construction to a more traditional axial layout. But I think it's worth taking a look at to see where he started. This is one of Dow's earliest drawings for the conservatory, and you'll see many of the same elements that the final one had, but in a slightly different configuration. There's always been on the public side of it a public gathering room, an entry lobby, and then the larger conservatory. But what you'll see different as we move through the conservatory is the layout inside is very different than the way it finally got constructed. You'll see much more of a sort of an asymmetrical, meandering path. These are actually raised paths here, and then there was supposed to be a sort of central lagoon water feature here on the side. In fact, what we will see as we move through the conservatory is almost something that approximates a cathedral in its formality, and it's an interesting change in concept that is something that we found intriguing. In fact, the building was built in 3 phases, which was an acknowledgement of how you had to protect the specimens that were being moved from other locations into their new home. So the first part that was built was the infrastructure, the boiler, and the temporary greenhouses. Then the second part was to build all the administration spaces for the people who would work in the building. And the final or crowning jewel of the project was the conservatory and the public and gathering spaces sort of on the front end of the project. And as you can see by his elevation, this is pretty close to what was actually constructed, he was greatly influenced by Frank Lloyd Wright in his long horizontal lines of the building. And this is interesting in the sense that contrast what you're looking at right now with what we'll see when we go into the conservatory with this great arcing vaulted space. The conservatory is built at grade, and it's insulated from the outside by 2 walls at our level. You can see the inner wall here, where you have the vents through which forced air is pushed into the space where it rises then to the top and is vented out the top of the conservatory. Behind that wall is a second wall that's in contact with the earth that has radiators on it, and that keeps, again, another barrier, thermal barrier, between the outside, which in Michigan is fairly hostile, and the inside, which needs to be kept at a very controlled temperature range for the safety of the plants. So I'd like you to get a chance to take a look at the conservatory in the round. So we're going to pan all the way around to give you a sense of how this is organized. One of the things that's so extraordinary about this space is Dow's vision for it. And in fact, if you look around, you can see many of the key components of ecclesiastical architecture or architecture of places of worship. You have a central alley, which would be sort of like the nave of a church. And on either side of it, you have sort of breakout areas, sort of like the small chapels that are dedicated to different subjects, in this case, different regions of the world, sort of areas of concentration. And it allow the University of Michigan to tell the story about the natural world in the way that they want to. The other thing you have is you basically have an opaque lower level where you can't see outside. There's a lot of conjecture on the part of the staff here that this was intentional to really set yourself apart from the natural landscape out in Michigan, because the inside, they wanted the inside to appear even more otherworldly than it would have been if it was in direct juxtaposition with the natural flora and fauna of Michigan. The other thing it really does is it directs your eyes upward. And with the quality of the mature specimens here, everything is really moving up out of the ground. And again, contrast that with the elevations that we saw where the lines are all horizontal in the building. So it creates a really wonderful sort of compare and contrast in the texture of the building. What you're seeing now is the fern pool, which is probably the equivalent of the altar in the church. And this is the thing that draws everybody through the building. And then, sort of interesting, just like you have in many cathedrals, you're asked to turn left or right and move around behind the altar to where a lot of times there would be smaller chapels. And that actually takes you back to the arid room. So the progression in the building is from tropical to temperate to arid, and basically giving you all of the biomes here in that we have in the world. Dow's design for the cooling system of the conservatory was ambitious and doesn't work quite the way he had intended. What he thought was if he were to draw air in low at grade level from vents along one side of the building, pull it across the ground floor of the conservatory and exhaust them out the other side of the building through large media panels that were filled with wet media. These came down in the water came down in drip trays and then was recirculated through, that would provide enough cooling for the building as well as humidification for the plants. In fact, what happens is that the flow of that air across the bottom of the conservatory is not rapid enough to entrain the hot air that rises up. And so you end up with a situation where you just have air coursing across the bottom of the conservatory and leaving the hot air stratified in the upper reaches of the conservatory. So these are the things that the Matthaei Botanical Gardens is now addressing with insulated blankets on the glass on the outside, also replacing much of the glass within the steel structure, and also automatic automatic controls for opening and closing additional vents up in the glass roof. As far as we know, the practice of growing plants that don't belong in a certain spot dates back to the Roman times. In fact, the Emperor Tiberius, back in Roman times, required cucumbers year-round. So they had to come up with innovative ways to get the cucumbers to stay alive in the wintertime. And one of the ways they did that was to put them in baskets or rolling carts and basically put them out in the sun in the beginning of the day and then roll them back in at nighttime or in colder times and cover them over with what were sheets of clear stone, which is a precursor of glass. They didn't have glass in that time frame. Unfortunately, this technique was lost over 1,000 years until it was resurrected, like so many others, by the Renaissance. Once aristocrats were exposed through growing trade with the Orient to exotic fruits and plants, they sought ways to grow them at home and in far more challenging climates than the moderate Mediterranean. The first conservatories were not very successful. They were permanent sheds with heavy wood plank walls and roofs. These were removed at great difficulty in the summer and heated by huge stoves in the wintertime. Use of glass was not possible as it was hand-blown at that time and heavily taxed, and there really wasn't the architectural knowledge to frame and support it in the large expanses needed. The next type of conservatory was the orangerie in the 1700s. Designed by the wealthy to grow all types of citrus fruit, this was a heavy brick building with south-facing windows. Plants in tubs were wheeled out in the summer and then returned to the protective building in the winter. This was an improvement over the wood, as brick provides significant thermal mass to help protect the plants in the wintertime. But this still really wasn't ideal. And enormous advances during the Industrial Revolution in architectural engineering contributed to the first truly successful conservatories in the Victorian age. These included boiler construction and management, hot water and heating systems, industrial scale production of uniform glass, and cast iron. As we shall see in his design, Dow used all of these techniques in one way or another, and he coupled them with advances in steel manufacturing that really came out of World War II. So here we are in the arid house, as you can tell by the succulents and the cacti around us. An interesting fact about the cacti is that they are a plant that only lives in the Americas. And as you look at these raised beds, you could see that Dow used every technique he could to try to keep the air circulating around these plants. Now, the way that he provided heated air is both by radiators on the perimeter of the building, directly under the windows, but also inside the planters there is forced air being pushed out into the space and then being allowed to rise to the glass, be cooled, and then through natural convection come down to be heated up again. In those times in the summertime, when you actually have to vent the space, there are vents in the top that open mechanically to allow the space to be vented adequately. It takes 4 enormous boilers to heat this building to preserve the plants. And just to give you an idea of how critical that is, if the temperature changes outside of the realm of tolerance for these plants, the whole collection could be lost. And ironically enough, this is the room that actually tolerates the largest swing of temperature, partly because of the deserts have much cooler nights and warmer days, and so this room is probably least critical when it comes to heating and cooling in the conservatory. The tropical space is the most critical. As a boy, Alden Dow would design floor plans with leaves out in his yard. When asked at age 8 what he wanted to be when he grew up, the answer was unequivocal: an architect, of course. A noted and very prolific Michigan architect, Ann Arbor is home to many of Dow's buildings, many of which are addressed in others of our tours. One of the building types he was especially noted for were places of worship for all faiths and denominations. He believed strongly that the building should encourage growth and member involvement. As many of his buildings feature an extravagant use of light, color, and natural plantings, there are some natural parallels between Dow's previous experiences and his first and only conservatory. As is true with most of the best architects, the design of many of his buildings pushed the envelope of accepted practice. Matthaei is no different and part of a long tradition of innovative buildings to conserve plants over time.